We've got to know which way to look. Okay, there we go. We're recording, and then we also need to get wide. Isn't that great? We can zoom out. And then they wanted us to... It's like an airplane flying by. It's kind of cool, isn't it? There we go. So write this down. Write this problem down in your notes. And we can see it.
I like songs that will stay and go when I know this song doesn't. It's like I imagine playing this song on replay on a car. Like halfway through it, you're like,
There we go. Alrighty. Do we have sound? We have sound. All right. And I'm still on the camera. This is good. Okay, so a level surface. And what is this? This guy's 5.0. Right, and then there is 34.5 newtons of friction. And I'm just giving you that. There's eventually in college you'll get like a formula that you can use that will give you that. Now these are tricky little problems, right? So what can anybody tell me about this problem for sure? What do we? 32, and that's 5, and yeah.
that's all right.
Well, okay, I think it's going to accelerate this way.
Okay. Yeah.
Right? And I'm not just guessing. I know that gravity is going to pull down on this block, and I know that force is bigger than 34.5. Yeah?
How do you know that?
Because I've multiplied 5 by 9.81 before. Yeah? Okay. So the question was, how do I know that? Okay. Okay, so what do we need to do? What do we need to calculate? Do we probably need to calculate the weight of this guy? Yeah, I think so. Right. So let's do that. Definitely there's a downward force of gravity on this guy, and that's going to be 5 times 9.81, which is 49.05 newtons. I'm really good at multiplying 5 by 9.81. It's one of my specialities. Okay. That's right. Is that the only force acting on this guy, this 5 kilogram mass? No. There's an upward force, right? Isn't it the tension in that string?
Yes.
So I'm just going to call it T. And I think that it's less than this force. There's a very good reason why I think it's less than that force. Why?
It's because the thing's moving down.
It's accelerating down. Specifically, it's accelerating, right? And we know that in situations where things accelerate down, we know if I make this accelerate down, the force gets less, don't we? We spent like a whole day yesterday telling stories about that, and accelerating up is more, but down is less, right? So this tension is definitely less than this force, and I'm just going to call it T, and it's one of the unknowns. It's one of the things we'll have to solve for, right? How about this guy? What are the forces acting on this guy? Yeah, if it's sliding to the right, if the thing's sliding to the right, the friction force will be acting to the left, and I think that force is smaller than T. So I'm going to draw a shorter arrow for that. 34.5 newtons this way, and it's just the friction always opposes the sliding, so if it slides to the right, friction's to the left. Is that the only force acting on this guy? No, there's also gravity. Yeah, gravity pulling down. The table pushes back up, and I'm going to ignore those for now, okay, because it doesn't accelerate up and down. We're just looking for the side to side, right? How about the string? Is the string pulling that thing to the right? And it's the same tension, okay? But it's only the same tension if this is a frictionless pulley, isn't it? If the pulley has friction, then this tension's a bit more than this tension always. if it's sliding that way. And if the pulley has mass and has resistance to change in its motion over its rotation, that would change it too. So that's why we talk about either alternately a massless or frictionless pulley, right? Well, how about if it's massless and frictionless? Would it spin? I mean, that's one of those questions that it's never answered, right? Okay. So this is the tension here. And isn't that a little weird to have like this is up on this one, but this one is to the right on that one? Isn't that weird?
Yes.
Yeah. Lauren's going to grab the other end of this. She's going to pull. Yeah, strings act that way, yes? Which way do you feel pulled?
Your way.
Toward me. And I feel pulled toward her. Yes. Strings have been doing that for eons. Yes? Yes. A little applause for a piece of string. There we have it, right? Okay. So that's the way strings work, right? Is that they just pull, right, toward the middle. Very hard to push with a string. Okay? Okay. Now, here's the problem. If I knew what this tension was, I could calculate the acceleration. If you told me that was 86, or no, I guess it would be smaller. If you said that was 30, I could calculate the downward acceleration, couldn't I?
Yes.
And if you told me the acceleration of this guy, I could tell you that tension. But I don't know both, do I? So we can either guess and check. That's one option. The other option is we can quit. Quitting is like this. Right? Or the third option that we can do is that we can set up two systems of equations using Newton's law, second law, right? And we can solve them using the skills that the math teachers taught us. Worked so hard to teach you. Which will it be today? You want to quit? They want to quit. Okay. Yeah, let's watch dog eating with No. Let's do the physics. Okay. Now, here's how you solve these problems. Step one is to figure out stuff. And by stuff, I mean like the weights, or if it's an inclined plane, we have to figure out the force parallel or something like that, right? Okay, so just figure out stuff. So we already did that, right? Okay, and we drew our little forces, right? Okay, the second thing that we need to do is we have to decide or guess the direction of acceleration. This becomes the positive direction. So which way is this going to accelerate? I think we know, don't we? This guy is going to accelerate this way, and this guy is going to accelerate this way. Now, this is controversial, because that means we're going to make, if down is positive, we're going to make this guy positive and this guy negative. That's somewhat controversial in this class, isn't it? But I'm allowing you to do that this time. But just this time. All future times we'll have to decide that on a case-by-case basis. Okay? So don't just take this as a license to make down negative any time you want to. Okay? Another way to think about this, by the way, is to think of it as protagonist and antagonist. Yeah? This guy's causing the acceleration, this guy's preventing it. This one will be causing the acceleration of this block, this one will prevent it. So this guy is positive, this guy's going to be negative. Yeah? Yeah? Now, the third step is to set up F equals ma for both masses. This looks like this. 32. Set up an expression. So for this guy, which one's positive? The t is, right?
Yeah.
And then it's minus 35. So we go t minus 34.5, right? Equals 32a. So this is just Newton's second law, right? It's like boop, 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 boop. And then for the 5 kilogram, what do? Well, this guy's positive, right? This guy's negative. Protagonist minus antagonist. I think the English teachers would be very proud of me. Either that or they would suffer a silent death with me corrupting the meaning of this.